How can we prove that sine theta squared plus cos theta squared is identical to 1? How can we prove this? Well, firstly, we must draw a coordinate axis. Then we must put a perfect circle around it. You have to imagine that this is a perfect circle. Then, in this circle, you have to put a right-angled triangle inside it. And the adjacent of this right-angled triangle has to be x, and the opposite has to be y. And the radius of this circle, which is the hypotenuse of this triangle, has to be 1. The angle of this right-angled triangle is going to be theta. Now, from this triangle and from this circle, you can see that this point has to be 1, 0. This point here has to be 0, 1. This point here has to be minus 1, 0. And this point here has to be 0, minus 1. Now, if we look at this triangle over here, we know that sine theta is opposite over hypotenuse. In this case, that would be y over 1, which is y. And we know that cos theta is adjacent over hypotenuse. And in this case, that would be x over 1, which would be x. Therefore, sine theta squared must be y squared, and cos theta squared must be x squared. So from this, what we have to do is replicate this triangle to the left. So we'd get x as the adjacent, y as the opposite, and 1 as the hypotenuse. If we look at this triangle right over here, we'll know that x squared plus y squared is 1 squared. And that's the same as x squared plus y squared equals 1. But we know that x squared is cos theta squared, and we know that y squared is sine theta squared. Therefore, sine theta squared plus cos theta squared is identical to 1. This is where we get this idea from.